So hopefully you're feeling a bit more confident about working with standard form numbers, changing them from ordinary to standard form and back again. But what you need to be able to do is to perform calculations with numbers that are in standard form. And you must be careful because there's rules that apply to certain calculations, such as multiplying and dividing, that don't apply when it comes to addition and subtraction. So let's work through some questions together. The first one we'll have a look at is a multiplication sum involving two numbers in standard form. And you can see the question up here. It wants us to express that sum as a number in standard form. So 2.4 multiplied by 10 to the power of 5 times 3.65 times 10 to the power of minus 3. So we have our two numbers in standard form. Now this is where the work we've already done on index notation is going to help us, because we can use one of the laws of indices to help us calculate an answer to this. I'm going to take first of all though my two numerical parts here, 2.4 and 3.65, and multiply those two together. If you like, I'm separating common parts of the sum together. That is then going to be multiplied, remember, by these parts, the tens. So I separate them and multiply them separately. And then I'll come together with an answer at the end. Now 2.4 times 3.65, you wouldn't be expected to do that without a calculator. This would be a calculator question. So if you type it into the calculator, you should hopefully see that it gives you 8.76. Now what happens here is where our laws of indices come in. And we know that when we multiply something with the same base, we're going to add those two powers together. And 5 add minus 3 gives us 10 squared. Now when you get this final answer here, it's always important to check whether or not the number is still in standard form, because sometimes the answer you get here may be a number that's bigger than 10 or less than 1. In this case, 8.76 is still between 1 and 10, so there's our answer in standard form. Now in the next example, it's a division question, and they're going to want us to express this sum in standard form again, correct to three significant figures. So we know that when we divide two common terms with the same base, we subtract the powers. So if I have this sum here now, 1.63 multiplied by 10 to the power of 4, divided by 2.4 times 10 to the power of 7. So when it comes to solving a question like this, the first thing we need to do, as before, is separate those parts and work them out independently. So we're going to separate the number parts. So we're going to have 1.63 divided by 2.4. Remember, this is a division question now. Now remember, it will always be the number multiplied by 10 to the power of something. So we have a multiply sign there now, and remember it's 10 to the power of 4 divided by 10 to the power of 7. So we've separated the common parts from each number and are now going to work out what our answers are in both cases. So 1.63 divided by 2.4, well, it gives you a nice big long number on the calculator. It would give you 0.67916 and so on. We don't need to write out every single number. Multiplied by, well, remember your laws of indices. When you divide, you subtract the powers. So 10 to the power of 4 divided by 10 to the power of 7 would give you 10 to the power of negative 3. Now you'll notice this answer still isn't in standard form. Remember, this number needs to be between 1 and 10. So, moving the point where I need it to be, and remember, they want us to round our answer, it will give us 6.79 multiplied by 10 to the power of, well, let's think about what's happened. This number has become 10 times bigger, which means this will need to become 10 times smaller. And when it becomes smaller, remember, we're going to lose 1 off the power. And if we take away 1 off of minus 3, it gives us minus 4. So our final answer here would be 6.79 multiplied by 10 to the minus 4. So we've seen how the laws of indices can help us calculate multiplications and divisions using numbers in standard form. Let's have a look at an example that involves addition of two numbers in standard form. Now unfortunately there's no rule to help us out here. So what we're going to need to do is to write our numbers in ordinary form, so as ordinary numbers, perform the calculation and then write our final answer back in standard form. So if we look at the question up here, it tells us that 3.26 times 10 to the power of 4 add 1.7 times 10 to the power of 5 is the question they want us to work out. So I'm going to change both of those first of all into ordinary numbers. Now 3.26 times 10 to the power of 4, you should all be happy, gives us 3, 2, 6 and 2 zeros on the end, 32,600. 1.7 times 10 to the power of 5, well that's going to give us 1, 7 and 4 zeros, or 170,000. So I've written both of my numbers as ordinary numbers now. And now all I need to do is exactly what the question asked me to, which is add the two numbers together. So adding from right to left, 3 add 7 is 10, so carry the 1, gives us 202,600. Now remember though, that's not in standard form, and they also want us to write it in correct to three significant figures. So this in standard form would be 2.026 times 10 to the power of 5. This, remember though, needs to be rounded to three significant figures. So what my final answer would be is 2.03 multiplied by 10 to the power of 5, and that's correct, to three significant figures. So, one of the harder types of questions you may get on this particular topic we've been looking at is one like this, where they actually give you the two standard form numbers as x's and y's, and then give you an algebraic expression that they want you to evaluate using those numbers. All you need to remember in this is they're only going to ask you to perform skills you already know how to do. So if we look at this question, they tell us that x equals 4.2 times 10 cubed, and y equals 2.67 times 10 to the power of 5. And they would like us to calculate to three significant figures, xy over x plus y. When we look at the question, all they're asking us to do on the top of the fraction is multiply those two numbers together. And then on the denominator, they're asking us to add the two numbers together. Now both of those we can do, so we're going to perform each of those calculations and then do a division at the end to get our final answer. So the first thing we'll do then is multiply the two together. So 4.2 times 10 cubed multiplied by 2.67 times 10 to the power of 5. So remember, we separate 4.2 times 2.67 and then bring our tens together so we can use our rule to calculate what our power of 10 is going to be. 4.2 times 2.67 gives us 11.214, with a calculator of course, multiplied by 10 to the power of 8 when we add our powers together. So we've calculated what the numerator of our fraction is. Now what I need to do is to add those two numbers together to get an answer for my denominator. So remember, when we add two numbers in standard form, we have to first change them into ordinary numbers, perform the calculation, and then put them back into standard form. So 4.2 times 10 cubed gives us 4,200 when we write it as an ordinary number. 2.67 times 10 to the power of 5 gives us 267, and those three zeros when we write it as an ordinary number, 267,000. I'm now going to add those two numbers together, which is what the denominator tells me to do. Again, working from right to left, 7 and 4 is 11, so write the 1, carry 1 over, 7, 2. So 271,200. But remember, I need that answer in standard form. So this number in standard form is 2.712 multiplied by 10 to the power of 5. So I've calculated the numerator part of my fraction and the denominator. So the final part of the sum that I need to do, if you notice in the question, the top xy is being divided by x plus y. So I need to now do 11.214 multiplied by 10 to the power of 8 divided by 2.712 times 10 to the power of 5. And we know what happens when we divide. We can collect the two things together again, our numbers and our 10 to the powers, and we're going to work out using the law of indices what they give us. So when we do 11.214 divided by 2.712 on our calculators, it gives us, to three significant figures, 4.13. 10 to the power of 8 divided by 10 to the power of 5, remember we subtract those powers, and it will give us 10 cubed. And we notice, just our final check, the number is between 1 and 10, so it's already in standard form.